Hello, today we are going to explore a temperature sensor module based on an NTC thermistor and an LM393 comparator. The main components on this board are the thermistor, the adjustable potentiometer and the LM393 comparator. The thermistor changes its resistance with temperature. Because it is an NTC thermistor, its resistance decreases as the temperature increases and increases as the temperature decreases. The module uses this change in resistance to produce an analog voltage. The comparator then compares the thermistor signal with an adjustable reference voltage set by the potentiometer. When the sensor voltage crosses the selected threshold, the comparator changes the digital output state. This allows the Arduino to make a simple decision, for example whether a fan should be turned on or off. The module also provides an analog output. This gives us a raw ADC value related to temperature. However, the thermistor is non-linear, so this value does not directly represent degrees Celsius. To estimate the actual temperature, the sensor must first be calibrated. The module has 4 connections: VCC power supply, ground, D0 digital output and A0 analog output. In this project, the module is powered from the Arduino's 5V supply, the analog output is connected to pin A0 and the digital output is connected to digital pin 2. To demonstrate a practical application, the Arduino uses the digital signal to control a 24V DC fan. The fan cannot be powered directly from the Arduino, so it is powered by a separate 24V DC supply. Relay module based on the SRD-5 VDC SLC relay is used to switch the fan circuit. The Arduino controls the 5V relay module, while the relay contacts switch the separate 24V fan supply. The Arduino also sends the analog value, digital state and fan status to a Python Thermistor application through the serial port. The GUI displays the estimated temperature, the raw ADC value and whether the fan is currently running. You can find the Arduino sketch and Python GUI code in the video description. Thanks for watching. If you found this project useful, please like the video and subscribe to the channel.